welcome to our heat pump, or pumps. Actually, we had a gas boiler fitted 25 years ago, and that, no, it's now 28 years ago, 27 years ago, and that was beginning to pack up, and I thought, we don't want to get another gas boiler, because that's going to lock in another 20 years of carbon emissions. And I had a friend, I was lucky to have a friend who gave me an education about heat pumps. But I too was still, God, can you really heat this leaky old building with a heat pump? And I should really know, because I did science, but even so, there's still that kind of element of, with all the doubt you read in the press and stuff like that, all the kind of stories. But essentially what this beast is doing, it's pulling air through it, and it's extracting thermal energy from the air. Now, the air around us is a huge number of molecules that are jiggling around, and they only stop jiggling at minus 273 centigrade. So what we think is freezing, which is currently about 280 Kelvin, is actually scorchio in molecule terms. They're still jiggling around like crazy. So if you take some air through here and you reduce its temperature by 3 degrees, but you pass through hundreds of cubic meters of air a minute, you can extract a huge amount of energy. And that's what it does. And it does it using the same technology that the fridge uses, which is what's called the refrigerant cycle. Basically, there's a gas which is liquid only when you at minus 50 degrees, say. And I won't try and explain the refrigerant cycle, but essentially it's cold enough to absorb that heat from that cold air very efficiently. It absorbs it, and then when it's a gas, it gets compressed, and that heats up a lot, a huge amount. That heats the water, then passes in these pipes into the house. And from then on, it's just like any central heating system. It's just hot water being pushed around the house. Now this beast, I think it's capable of, I don't know, a few hundred cubic meters a minute. So if you imagine you've got that air going through there, it's going through this heat pump and coming out the other side a few degrees cooler. Well, the heat has to go somewhere. Well, this refrigerant cycle heats up water. So this might be only 5 degrees C coming in.
So where is the water?
The water is just cycling round. It's a closed loop.
Mm-hmm.
So it's going a closed loop into the house and then back out again. So you have a flow, what's called the flow temperature coming out, say at 40 degrees C, and it goes into the house, it gets pumped around the house, it gets to a radiator, the radiator gives off heat into your room to keep it to 21 degrees C, say, and then the flow comes back, and that might be 438 degrees, or it will have taken some of the heat out of this thing, and it goes round the cycle again, so it gets warmed up. So it's the water is brilliant because it has a high heat capacity. It's sort of like it's 3,500 times. If I have a cubic meter of water, its heat capacity is something like 3,500 times more than a cubic meter of air. So what we have here is high volumes of air going in, but low heat capacity. But the water going around here is low volumes, perhaps 20 litres a minute going around the house. So it has low volume, but very high heat capacity. And they're doing the job. So we're going from this system to that system. And you've heard about ground source heat pumps. Well, they're sort of doing the same job, except they're getting their heat from a loop that is going underground and then going into here. But other than that, once you go past here, it's then just typically water being used to move heat around the house.
Did you have to redo all the pipes into the house?
No.
You use the existing...
No, because Danny, our plumber, 28 years ago, did such a brilliant job that we had all the right size pipes in all of the right places.
Wow.
And we had double panel radiators pretty much everywhere.
Okay.
And we only had to upgrade about a third of our radiators, which I was very surprised at, to triple panel. And so we were lucky. I think microbore can be a problem. Short stretches of microbore aren't necessarily a problem, but because basically this moving heat around thing, you know, if you have a small pipe, you know, this is all common sense really when you actually think about it. But if I want to move a certain amount of heat down this tube and the same amount down this tube, I have to do it at a faster rate here. And it has to be pumping like crazy to get it can still do it, but you have to pump at a faster rate, and then that can create other problems. So having the right size pipes in the right places, and that's all part of the design process. When someone's designing it, they have to work out what's the heat loss for every room, how much heat do I need to deliver a minute in order to keep it at the right temperature, given the fabric and everything. Therefore, I need this size radiator and these size pipes.
So has it got a higher flow rate than a gas system? Because I mean, I've got microbore.
Probably not actually, but it's on more of the time.
Yeah.
And is 40 degrees actually the flow temperature, or is it just was that just a number you use?
I just use it as representative of a mid-range, shall we say. So the lower so if someone says to you, oh yeah, we've got these wonderful high flow temperature heat pumps, you should really walk away at that point, because it shows they don't really understand heat pumps, because that is not really what one should be doing. One should be thinking about having the lowest flow temperature possible to meet the demand, because the lower the flow temperature, the higher the efficiency of the heat pump. So that's why with underfloor heating, you know, they're perhaps 27 degrees, and that's the ultimate in comfort. But you know, we couldn't do underfloor heating. So radiators is the next best thing, and if you can keep the flow temperature low. So what this system does, these know what the external temperature is, and then it does an internal calculation. There's a computer in there that works out, therefore I need a flow temperature of this much. And our system's been designed that the flow temperature is never more than 50 degrees. It's 50 degrees on the nominal coldest day of the year, so -5 degrees or something like that, I think.
I mean, I'm interested because we've turned our flow temperature down to 65 and it struggles.
But you've got to keep it on longer.
Well, yeah.
Well, so our old, you know, with the gas boiler, it was sort of, it goes like a Ferrari in the morning and heats everything up, and then probably is too hot.
Sorry,
I mean, it goes down.
drafty there, so
Oh, sorry. I mean, goes.
It must be freezing.
And then and that's the sort of.
refrigerate.
It actually was too hot. You know, it was overshooting almost. Whereas with our heat pump, it sort of stays on. It's staying on a steady keel.
Yeah.
It's on. It's always on. But it's not always running, if you get me. Because if it's reached temperature, it can then just modulate down and doesn't have to be running. And at night we set it back a few degrees. So we have one thermostat in the sitting room set to 21 degrees, and then between 10:30 and 6:30 in the morning set back to 18 degrees, something like that. And usually there's so much thermal capacity in the house, it actually goes off for quite a long time at night. It will come back on again, and typically in the morning it will do the hot water as well. But if one continues to have this on for short periods and lowers the flow temperature, you're not going to have enough heat to heat the house. It is about having it on for longer periods to compensate for the fact that it's So there we are. Now when we came, they could have done it with one heat pump, but it was around the time when RHI Grant was about to die, and I think these were the last 2 eco-dams in the country at the moment at the time. So they reckoned our maximum heat loss, this is on the normal coldest day of the year, was there's a number they give you, which was, and ours was about 18 kilowatts, which is quite big. You know, for a well-insulated 3-bedroom semi, you might be, I don't know, 6 kilowatts or something like that. So that's quite a high number, and these are both 11. So actually we're overpowered a little bit, but most of the time, you can see now it's 6 degrees outside. Sorry about that. But only one of them's on. So we're kind of overpowered.
And it's 21 degrees in the house.
Yeah.
Yeah, but it could go down at minus 6.
Yeah, but the point is that most of the year it's only one of them running, and the computer's clever enough to say, oh, you've been working your socks off, you take over, so they will do all that kind of handoff thing.
And it does your hot water as well, you say?
Yes. So let's go inside and just try